Yeah, my friend, today we're gonna talk about operators. This very complicated argument, right? Well, in this video, I'm not gonna explain that 1 plus 2 is gonna be 3 and that the plus sign simply means, hey, add these two values together. This is rather stupid and too simple. What I'm gonna do in this video is just give you a gimmick to recall once for all, which is the precedence of all of these operators, which are a lot. This is the tricky part of operators, because when you have an expression, you have a lot of operators, right? And in that case, can be difficult to recall that one specific operator has an higher precedence of another specific operator. This is the thing that you need to master, and that's what I'm gonna try to do with this video. Here, as you can see, you have the complete list of all the operators available in C. Immediately, you see that these operators are divided into blocks, and these blocks are precedence-based. Namely, at the top, you have the operators which have the highest precedence. At the bottom, you have the operators which have the least precedence. What does it mean? Well, very simply, when you have an expression that has to be solved, like in mathematics, essentially, when you have an expression that you want to solve, there are certain kind of operations that have to be performed before others. Mathematics, you know that the operations which are inside braces have to be performed before all the other ones, right? That's the same idea in code. When you stumble upon the braces, even in programming languages, you know that these operations has the highest precedence in the overall expression, okay? So the highest precedence operators are the braces, the square brackets, the arrow, the dot, the plus plus and minus minus. In a long expression, when I stumble upon this kind of operators, I know that, okay, I have to do immediately this operation because these are highest in the precedence pyramid, okay? I think it's super easy. You don't need further explanations. The arrow and the dots are operators that are accessing some member variables in structures. You don't need to know by now what are structures, so just keep in mind that you have these operators that you can use, but don't focus too much attention on the details. Just ponder the overall idea that you have a bunch of operators. Every operator has its own specific precedence. After these member operators, you have the plus plus and the minus minus. These are indeed very commonly used operators that you're going to use on a daily basis. And we're going to talk profoundly about these operators in a further video, because there is a paragraph which talks about postfix and prefix increments. As you can see, the postfix increment and decrement operator has a higher precedence respective the broader operator plus plus minus minus, but prefix this time. I repeat to you, you will understand these ideas in a further video, even though it's rather simple. To make it clear though, postfix and prefix plus plus and minus minus are both unary operators. Unary simply means that the operator acts on a single variable. It's not binary. For example, an addition acts on two values, 1 plus 2. You have two values. So the addition here is binary. It's a binary operator. Plus plus and minus minus are operators that act, I repeat to you, on a single variable. For example, you have the variable n. If you do plus plus, it's going to increase by 1. Now, pay attention to the unary operators, the ones which have the second highest precedence in C. You can see the plus and the minus. Strange, right? The plus and the minus are unary operators. Aren't they binary? Namely, n plus n1, you add them and this is an operator. Well, yeah, indeed, plus and minus can be both unary and binary, okay? Because I can have a plus 1. That plus 1 acts like a unary operator. Simply means, okay, this one has to be positive. By default, all the numbers are positive, right? So it makes more sense with negative. When you say minus 2, that minus is an operator. It's like a microfunction that is changing the bit configuration of the value 2, the positive value 2, to the bit configuration of a negative 2. Namely, it's going to invert all the bits and adding 1. Is the choose complement way of representing negative numbers. I prompt you to watch my video if you don't understand this point. So long story short, the unary operators are acting on a single variable. You have the plus, the minus, that are both unary and binary. Then we have the exclamation point, which is going to invert a specific value. For example, we can switch from true to false. The exclamation point is very useful. I use very often. Then we have the tilde that is gonna make the complement of a value. This is cool, never use, but nonetheless. Then we have again the prefix, increment and decrement, plus plus and minus minus. As you can see, the prefix, as I just told you, have a lesser precedence than the postfix. Okay, then we have the typecast, namely an operator that is changing the data type of a specific variable. Then we have the ampersand that is giving us back the address of a variable, and then the size of operator. Yeah, this is an operator that is giving us a size, a specific size, how many bytes in memory a specific object is occupying, okay? And then, my friend, all the other operators you perfectly can understand by yourself. You have the multiplication, division, modulo. Underneath, we have addition, subtraction. In this case, plus and minus are binary. As you can see, the unary plus and minus have an higher precedence respective to the binary plus and minus. And this makes sense. For example, you can write 3 plus minus 2. That minus 2 is unary, so it's gonna be resolved before the plus, which is binary. I think it's very easy to understand. Then we have the shift, relational, equality, bitwise, the ternary we're going to see in this video, and the assignment operator that you know pretty well. At the end, we have the comma operator. Indeed, the comma is an operator that is used, for example, when you want to declare variables. Right? One important caveat that you need to know is that this list is different from the one that you can find in the Carnegie and Ritchie book, right? The C programming language. Long story short, I'm going to show you our response in Stack Overflow so we can understand why. So here's the question. Why in the C specification only the prefix, increment, and decrement operators are summarized as unary operators? As you can see here in the unary, we have only the prefix, increment, and decrement, while the postfix are in the postfix operator. But even the postfix are just unary operators. They act on a single variable. So the question is legit. In fact, the postfix, increment, and decrement operators are summarized into the section postfix operators. I don't see the difference, both operate on a sole operand, true. So best response, of course, both postfix and prefix, increment, decrement are both just as unary as the other. Of course, they are the same operators, just we have different characteristics. That's how they are used. The fact that they have different priorities mean that they are put in different groups. And the groups have historical names which are a bit off. Yeah, that's the problem. Nomenclature is the problem. Here's another response. The reason why the C uses confused names for the operator groups is most likely this classic yet incorrect table. This is the table you will find in your book. The table is to blame for a lot of evil in the world. Carnegie and Ritchie originally listed everything unary as one operator group. But the problem is that it doesn't make sense for the postfix to be grouped with the prefix operators. So long story short, you can read by yourself. Out of the two groups in the Carnegie and Ritchie table, they made 3. So now we have one group for primary expressions, one group for postfix one, and one group still called unary, likely because of historical reasons. It is kind of confusing. Keep in mind that this book has been written in the 80s, so you know everything changes so fast. Anyway, I will link this Stack Overflow response in the description so you can go as deep as you want in this riddle. Coming back to us, I want you to give a gimmick to recall forever this sequence of precedence. Thanks to a memory technique that I always use, which is the one of crystallizing a lot of information in a single strange image that I can recall very easily. Remember that your brain is just a forgetting machine that is always trying to forget stuff. It is always trying to make garbage collection and to forget stuff. It will recall all the things which are out of ordinary. So if you stumble upon a unicorn, you won't forget. Or if you stumble upon an alien, you won't forget, my friend, because it is out of the ordinary. If you every day do the same thing, you won't forget. You can distinguish Monday from Tuesday if you do every day the same things. So this is the gimmick I use, my friend. This is a single phrase with a very strange and unusual image that is very easy to remember. The string is Puma as rebel. And the image that I have in my mind is this Puma, which is rebel in the Peaky Blinder style, right? In the hat, he has this sign for division. At the bottom, I have the word tack. And if you read this word on the contrary, you have cat, right? Puma indeed is a cat. So you have Puma is rebel, tack. What is it all about? Well, we have the order of the letters of this string, which is exactly the precedence of the operators in C. We have primary, unary, multiplicative, additive, shift, relational, equality, bitwise, logical, and then ternary assignments and comma. With a single sentence, you can recall exactly the order of all the operators. Puma is rebel, my friend. As simple as that. Now, here, my friend, I have a little exercise, a little program by which we can appreciate better these precedence of all the operators. Let's run this code and let's watch the output. As usual, I compile and then I launch. Okay, the first exercise is pretty simple, right? I just parse the expression. In the expression, I see that I have a multiplication and a division. I know that these two operators have the highest precedence. So now the question, I have to resolve this one or this one before. What's your opinion? Well, my friend, when I have operators which have the same precedence, there is another rule that kicks in. This is the associativity rule. Again, there is a little gimmick to recall this. And the gimmick is auto comes from the right side. It simply means that assignment, unary, and ternary are evaluated right to left. Okay? So as you can see here, assignment, auto, unary, the second ones, right? And ternary are evaluated right to left, as you can see from the associativity rule. All the other ones are left to right, so it's easy to remember. It's easy to encode this rule. Auto comes from the right side. So what do we have here, my friend? We have a multiplication. You know very well that multiplication and division as high priority is in the third spot. And this is not an auto, right, for associativity rules. So the expression is evaluated left to right. So I'm going to do 5 per 2, 10. 3 divided by 4, what is 0? So I have here 10, okay. Here I have a 0. Then I have plus and minus. They have the same priority. For the associativity rule, I know that I have to go left to right. So I have 10 plus 10, which is equal to 20. Then I have 20 minus 0, which is 20. Okay, easy peasy, I think, right? Then we go here. This is a more complex one because I have the prefix and postfix operators. Try to resolve this riddle by yourself. Okay, I'm not gonna spend too much time to. It's easy, my friend. Or you can use ChatGPT if you have any problems. The only thing I want to show you is this one. The binary operators. As you can see in C, we can use binary operations, which are pretty cool because we can work on a byte level. We can work essentially with bits. We have this power with C. So here I have 9 and 8 or 7 XOR 9. Just watch the bitwise operations that we have. As you can see, they have different precedence. And try to resolve this riddle by yourself. Exercise 4. Here you have all the binary configuration of all the numbers to ease the comprehension of these bitwise operations. Then the exercise 5, we have these ternary operators. Ternary operators are super easy to understand. Look here, I have a question basically. Read ternary operations like that. Is 10 major than 11? Yes or no? In this case, no, it is false. So if the response was yes, this would have been resolved in 11. Okay? On the contrary, it is resolved to 10 because this is false. So every time you have a ternary, make yourself a question. Is 10 major than 11? True or false? If true, give me back this number. If false, give me back this one. In this case, 11 is minor than 12. Yeah, it is minor, so I get 12. This expression is going to resolve in 12. So here I have 10 is major than 12. No, it is not. So I get 0, which is false. Okay, my friend, now I think you have a very cool tool to remember these operator precedents once for all. But I pledge you to write code that doesn't need these stupid gimmicks to be understood. You should write indeed code that doesn't require any kind of knowledge of operators precedents. And you can always use the brackets just to say, hey, I want this operation to be performed before the other one. Please don't exploit this power that you have now with Puma, his rebel gimmick. Now the quote from the book that I think it's interesting to delve into. The result for modulo are machine dependent for negative operands. What does it mean? Well, you perfectly know that with the modulo operator, we can get the remainder of a division, right? If I have 10 divided by 3, I get the quotient, namely the result of the division, which is 3. And then I have the remainder, which is 1. Well, with the modulo operator, I can get that 1. 10 modulo 3 is equal to 1. Cool. Easy peasy. What the heck is going on? Well, the thing is more tricky when we perform the modulo operation with negative numbers, okay? Every time you have a division with negative values, for example, -9 divided by -3, you do 9, which is the absolute value of -9, divided by 3, same logic, and you get 3. And then what do you do? For the result, you just balance the two sign. So you have -9, -3, minus is equal plus. The result is plus. -9 divided by -3 is equal to 3. Easy peasy. For the remainder, we have the sign that is determined by the dividend only. For example, -10 divided -3. What is the modulo that I'm going to get? What is the result? Well, you know that I do the operation with the absolutes. So I get 1 as the remainder. The sign depends by the dividend. So the number that will be divided. What is the sign of the dividend? Well, it's minus. So the remainder is -1 in C. This is not the case for all programming languages. Let's watch a practical example. So here I have a little program that is going to show you a modulo implementation. Let's just run this code and let's watch the output. Okay, here it comes. I have modulo implementation in C. -8 modulo 3 is equal to -2. So I do the division. So I do the normal operation with absolute values. 8 modulo 3 is equal to 2, right? Because this is the remainder of 8 divided by 3. Then I give the sign to the remainder depending of the dividend, which is -8. Let's watch the same code, but in Python. So Python 3 modulo implementation.py. As you can see, the same operation gives me back a total different number. You have -8 modulo 3, which is equal to 1. How does it work? Well, basically, my friend, it boils down to what makes the most mathematical sense. And if you want to dig down in this rabbit hole, here there is an article written by Guido van Rossum, which is the creator of the Python programming language, in which explain all its points, okay? Why he did modulo in this fashion. A long story short, you have these two rules, mathematical rules. We do the operation with absolute values, right? We have 8 divided by 5, so we get 1 with a remainder of 3. Now the problem is that in Python we don't have truncation, but we have the flooring. And the flooring of negative number, what does it mean? Well, we go on the other direction. We go towards negative infinite. So we get the result, which is -1.6. Flooring, what is? Well, is 2, -2, because it gets rounded down. Now, in division, I know that the quotient, the result multiplied by the divisor plus the remainder, has to give me back the dividend, right? In mathematical terms. So what do I get? I have 5 per -2, which is the floored result. I get -10. -10, okay? So multiply that by that 5 and you get -10. So what is that 2 as a result of the model? Well, that 2 is the number that you would have to add to get that -8. So in this fashion, in Python, the modulo makes sense mathematical, but anyway, I wouldn't pay too much attention on all these details, otherwise you're gonna become crazy, my friend. We just focus on our beautiful C programming language by now, but because after we're gonna use Python, of course, because it is amazing as a language, it's very user-friendly. When we have negative numbers, negative division, we do the division with absolute values, and then we discipline the sign of the quotient, the result, making the balance between the dividend and the divisor. The remainders cares only about the dividend. So now, my friend, I'm going to launch another program that is going to show you these ideas. So modulo division, here it comes. All right. Here, as you can see, I have the dividend, divisor, quotient, and the remainder. Let's start. We have -5 divided -4. So I do the absolute values division. 5 divided by 4 is equal to 1. I balance the sign, right? So I get plus 1. For the remainder, which is 1, I care only about him, right? I care all about the dividend, so -1. Now let's watch a positive. 3 divided -2. Absolute values, I get 1. Balance the sign, minus. Division, -1. For the remainder, I care only about the dividend. Okay, that's it, my friend. That's it. I think it's very easy. Now you understand how this stuff works. For division, I balance the sign. For remainder, I care only about the dividend. And as you can see, for all the positive, the remainder is always positive. Look here. And on the contrary, for the negatives here, I have always a reminder which is either 0 or negative. Cool, my friend, now you understand the modulo operator in C. And especially you understand this line. The result for modulo are machine dependent for negative operands. What the heck could have this line meant? Right, it's kind of tricky. I recall to you that this book is thought for already full-fledged developers and not for people that need to start to learn to code from scratch. So here I have just the thing that I showed you. In C99, choose the reminder with the same sign as the dividend, while Python choose the reminder with the same sign as the divisor. So different languages, different views. Okay. Now the last thing of this video is the concept of short circuiting in C. What is this all about? Quote, evaluation stops as soon as the truth or falsehood of the result is known, and most C programs rely on these properties. Here, my friend, I have a real code example of one of my projects. Here, you don't have to understand what is written, but here I exploit this short circuiting property. As you can see, I have an if, and then I have the braces. So I have my Boolean expression that needs to be evaluated. I have an access of a member variable of a specific structure. And as you can see, I have 3 Boolean expressions. I have the first one. If this is true, what do? You check the second one. The second one, which is the one with the red square highlighting. This, my friend, is exploitation of short circuiting. Namely, I am telling it to this Boolean expression. Hey, before going in the third Boolean expression, just making sure that there is a new node. In this case, I'm checking, hey, there is a new node in my linked list, which is a data structure which is composed of many blocks. And so make sure that there is, because if I didn't do that, in the following expression, I try to enter a specific member variable, which in the case was not available. Here I would have a segmentation fault. Okay, this is confusing, I know, sorry for that, but it's just to show you that this short circuiting property is important and it is used in real code, so pay attention to this. Here I have a punchline. Short circuiting in C means don't finish what you started if you already know the answer. I think you know that for AND logic expression, all the expressions have to be true, right? The first has to be true, the second has to be true, the third has to be true. If they are all true, the whole expression is true. So if I stumble in an expression which is not true, what happens? Well, the evaluation stops because I know that the overall expression is false. Now I'm going to explain you very easily. For this specific problem, we are going to use Python, which has the same properties as C. Essentially, the Python interpreter is written in C, and we can maybe wrongly say that Python is a syntactically sugar version of C. But anyway, let's watch together this short circuiting property in Python. This is a very cool program, which is called Thony. Here I have a simple program with 3 variables. So you can immediately appreciate that Python doesn't require any function, main, or any int a is equal to 5 or semicolon. So we have a simplification respective to C. Anyway, let's launch this code. I'm going to launch with the debugger mode. So we start. We have the creation of the variable a, which in Python is an object, but not for this time, Python for another time. Step over. So as you can see here, we create the variable a is equal to 5, b is equal to 10, c is equal to 15. Then we enter this if then else. And now we are gonna appreciate the short circuiting property. This is how the compiler, in this case the interpreter, is parsing, is reading all the instructions. So we're gonna chunk by chunk, step by step understand this. The first thing it's gonna do is checking the overall expression. A is major than B. So the first thing is gonna check for this one. A is major than B. What is this expression, my friend? I mean, what is gonna be resolved? A is equal to 5. B is equal to 10. 5 is major than 10, my friend? No. So it's gonna resolve in false. And here, given that we have and when we have ends, all the expressions have to be true to make the overall expression true. What is going to happen? Let's keep going on. False. Boom. We go immediately in the else block, you see? At least one condition is false. These b minus c and c major than 10 are not evaluated. I don't need to, because when I know that this expression is false, I immediately know that all this expression is going to be false. Let's change now this piece of code with minor here. Let's relaunch again. This time I have I minor than b. So it's going to do all the variable checking, substitution. Is 5 minor than 10? Yes. So I have true here. So now we have to keep going on, you see? Because we have to check the other expression. B minor than C is going to do all C's calculation. 10 is minor than 15, yeah, of course, true. So I need again to check the last one. Then we comma, the last is 15 major than 10, of course. So this is true. You see, my friend? True, true, true. This time, no short circuiting has happened because I had to come to the bottom of this Boolean expression. Cool. So it's gonna print all conditions are true. Easy. We go in the next block because we can use short circuiting properties even with OR. In OR, we need only one expression that is true. If one is true, I don't need to check anything else because I know that the whole expression is true. So I check A is minor than B, A is 5, B is 10, 5 is minor than 10, true. What is going to happen now? You understand these ideas? Well, I get short circuiting. I know that the whole expression is true. What is happening? I directly print at least one condition is true. I don't need to check this true. All right, my friend, I think you perfectly understand these short circuiting properties. So, long story short, short circuiting in C means don't finish what you started if you already know the answer. And this is a property that you can exploit in your code. Of course, this works with Boolean expression, so with operators such that the logical AND and the logical OR. To understand how this logic operator work, it's super silly. You just search for the truth table, which is something like that. To make it clear, for an AND, all the inputs have to be 1 to be true. Okay, so 1, 1, 1, 1, 1. That's why we can short circuit when we find a false, because if I have one false, the expression to me is false. It's not visible anymore. While the OR, I need only one that is true to be true, and so forth. These are truth tables. I'm sure you know this stuff. The last gimmick I want to show you is this one. In order to understand, to recall very easily the precedence of the logic AND and the logic OR, there is a simple trick that you can do. Look carefully now. You see that the ampersand has this per sign, which is embedded in itself. So it's very easy to treat the ampersand like the multiplication of the logic. And the OR is these two lines. It's very easy to associate with the plus sign. So it is like, quote unquote, the addition. It has that kind of priority. So as you can see from the table, the logic AND has higher priority than the logic OR. You can very easily recall with this gimmick. This happens also with the bitwise operators, which have a higher precedence than the logical ones. And of course, the difference is that the bitwise AND just work on the bit level. So it's useful when you need really surgically to change some bits and do these kinds of operation. And my friend, I think that's it for this operators video. What do you think? And I recall to you that this is all bad. What I told you up to now is bad because if I need to know this stuff to read your code, this is not cool. I need to read your code without knowing that any Puma is rebel and that the auto comes from the right side. Okay. Thank you, my friend, for watching. Enjoy.